Okay, hello everyone. This is my first live stream. I think that I will make this a series because it will take me many more hours to complete this project. And I also want to do some other projects because I think I truly need to start training my abilities in producing real world applications and systems. So
Okay, hello everyone.
wait,
This is my first live stream.
something.
I think.
Okay, sorry about that. Um, So as I was saying, I kind of want to do this like a series, and I also want to start practicing my skills in some other areas. So not only on coding, but I also want to start practicing my English skills, and also my communication skills, and overall my like overall skills, I guess. So yeah, I'm making this a series. I'd rather do this in a live stream because I think it helps me keep me accountable on what I'm doing. It really makes me focus on the task that I'm performing, so I really think it's going to be beneficial for me and hopefully for someone else out there. So yeah, I mean, this is my first time doing this, so sorry if I'm not very experienced or if I uh, happen to make some mistakes along the way, but hopefully we can grow together. And yeah, so that's why I'm doing this journey. So as a first approach to what I'm doing, I kind of want to give some context to the project. So as you can see in the title, this is named URL Shortener. So I'm making a complete system that is trying to mock a URL shortener, just like Bitly, for example. I mean, the way it works is really simple. You just copy a URL, for example, this one right here, and then you just go to like the website of like the URL shortener. You just paste that there, and then it produces a shorter URL. That's why it's called a URL shortener that you can access to, and then it automatically redirects you to the original URL. So you can share the link with anyone, and also you can track some other statistics like the click count or geolocation data, such as where the people that click your link visit you the most, for example. So I think it's a very interesting project. I'm making it so that it's fairly simple right now, but it can grow and scale to the needs of anyone basically. So we can add many other modules and many other components to the application. So as I said, as a first approach, I'm going to explain rather succinctly the context of the application. So I made here a whole planner. Um, so as a summary, the as I talked about, the functionality of the system will be just to create URLs, so shorter URLs. And then this also must be unique, of course, so that we can map the shorter URL to the original URL and then redirect the user that's clicking the link, right? Um, we also have, well, the two main functionality, of course, create and use the shortened URLs. So the server has to have support for both creating the shorter URLs and then, of course, redirecting the people that's using those URLs. So yeah, it's a fairly simple project as a functionality wise talking, but then as for the system design that I'm going to use, I'm going to deploy this application in AWS. So I'm practicing a lot of my cloud skills. So I want to specialize and develop on the cloud area. So yeah, right now I'm doing a serverless application. I'm doing a serverless approach just because I think it's the easiest way to manage the server, and also because I think it's really cheap for me right now. So I don't need to configure any servers manually like an EC2 instance. I'm just doing a Lambda function and a DynamoDB as I detail here. So I'm using as a database DynamoDB, of course, Amazon Web Services. A web API, in this case, well, I'm also specialized in Go programming language, so I'm doing it in Fiverr, which is a framework for Go. Then a caching system. So I was consulting, and I'm going to talk about this a bit later here, but I was trying to do my own research about the free tier of AWS. And as you can see, there's actually a free tier for the cache layer, so to speak, but it doesn't apply to the serverless, so you have to manage your own node for that. And I think the node is running Redis, so I think we're going to learn a bit about configuring a Redis server. I think it's going to be fun, I think. Then I'm also using Lambda functions, as I talked about earlier, for deploying the REST API. We're going to use the Go runtime, of course, and a Lambda function with a DynamoDB integration. And also, we're going to use an API gateway. So we're going to use a proxy resource to redirect all the requests that we are going to define on our Lambda function. Of course, the Lambda function will only have two endpoints, so to speak, which are going to be the post request for creating new short URLs, and then the get request for redirecting the user to the original URL. So all of these will be deployed and modeled with the AWS CDK. So I'm going to use infrastructure as code to define the architecture that we're going to use. So all of these that I'm talking about in text right here, I'm going to define it in code. So yeah, I think it's actually really interesting and really useful in a way to define this as code, because not only you can deterministically approach to the same process each and every time, so it automates the process of having to deploy, and of course it actually helps a lot in not doing the wrong things each time. So instead of trying to do, sorry, let me just fix this. So instead of trying to just manually deploy the application each and every time, what you can do is simply define it as code and just run it again and again, right? So everyone can do the same infrastructure and architecture in their own computers without the need to replicate annoying steps to set up the whole thing. You know, just run a command and that's it. So yeah, I think it's really useful. And also, so as a summary, of course, we have DynamoDB, Lambda, API Gateway, and then Go and Fiverr and Elasticache for the caching layer. So the modules that we're going to divide our application on, of course, as I talked about earlier as well, right now we're not implementing a whole lot of things because I just want to practice deploying new services to AWS. So the main module that we're going to deploy is the URL Shortener module. So just the creation and the querying of the shorter URLs. We're not doing anything too fancy right now. As I said, we're going to design the application in such a way that we can actually add new modules in a rather simply and well seamlessly add new modules, of course. So if we wanted to add, like, for example, an authentication module, we're going to be able to do that rather easily. That's the objective of the application. And then also, if we wanted to add some other modules, like, I don't know, maybe geolocation module or tracking some more information, we can actually extend the functionality of the current system. And it's not going to be very hard because of the way that we're going to design it, right? So, keeping things up a little bit, as I said earlier, we're going to discuss a little bit about the cloud architecture as well. So the project can be modeled with the following diagram. So I'm going to expand it just so you can see. So we're going to use 5 main services of AWS. As I talked about, we're going to use the API gateway, which is going to be a proxy resource to redirect the requests to the Lambda function. Then we're going to use the Lambda function, which is going to be a Golang API, REST API, written in Fiverr, which is a web framework. Then we're going to use an integration with DynamoDB, which is the data store that we're going to use. Of course, it's completely serverless. We have a free tier, which is capable of processing, I think, 200 million requests per month, which is going to be more than enough for a project. Don't worry. And then even if we added more and more tables, I mean, we could just like destroy this stack, I guess, in CDK, which is also another useful thing about the CDK and defining infrastructure as code. You can just like destroy your whole application in a simple command and then just re-executing it whenever you want. So yeah, I think it's really useful. And then finally, we're going to use as the caching layer for our application the Elasticache service from AWS as well, which is just a self-managed node, which is going to be the only service that we're going to configure by ourselves. Just because, I mean, we don't have the free tier available for Elasticache serverless, so yeah, we're going to have to configure that ourselves. And then finally, just for logs and metrics and just to make sure that the application is running smoothly, we're going to use AWS CloudWatch as well, which is just going to configure a bunch of alerts for all our services, just to make sure that we're not going to too much outside of the free tier layer, I guess. But yeah, those are the main services that we're going to use, and that's the simple cloud architecture diagram that we're going to be basing on the whole application process. So yeah, finally, I think something really important to consider is the pricing of all of these things. First of all, we have the Lambda function, which we have 1 million requests per month. Then DynamoDB, as I said, it's 25 gigabytes of storage. plus 25 read and write capacity units, which is approximately 200 million requests per month, or that's what the AWS page says. Don't know if to trust them though, but we also have API gateway. We're going to find out anyways. We also have the API gateway, which is a million requests per month as well. So API calls, basically any other requests that the user makes that is going to be redirected to our Lambda function. That counts as a request. So we have 1 million of those per month. And I think that's 12 months of duration. So in 12 months, my free tier is over. Therefore, my API gateway is going to be really expensive. But I guess we'll see. Then the Elasticache, 12 months free for Cache T3 micro per node usage. So that means, again, as I said before, we're not going to be able to use serverless for Elasticache, which, it's a shame, but I guess it is what it is. Cannot have everything free for everything. And then finally, CloudWatch, which is 10 custom metrics and alarms, which is enough for all of our services, of course. I've actually never configured a CloudWatch service, so we're going to see how that works. I mean, I have no idea how that works, but that's why we're here, right? Finally, of course, we can make this whole application work in a free tier, basically. And then we're going to use rate limiting, of course, which is a technique to ensure a little bit of security and also to avoid too many requests and to overload the server in Fiverr, which is a really easy thing to do in this framework because you don't have to call a method, I think, and then you can just basically configure your rate limit to avoid overloading of the server, right? So yeah, that is basically all the previous planning. Now entering a little bit more on the details of implementation in the code itself. We're going to use a bunch of design patterns and some implementation details. So the database schema, as I said, we're going to use DynamoDB, so it's a little bit more complicated than a regular relational schema, I guess. So for this one, of course, DynamoDB is a query first approach, so you have to take into account the way you access information before the information itself. So you have to prioritize the main queries that you're going to use and how you're going to access that information, right? So you need to reduce the number of queries at the expense of incrementing the number of duplicate records in your table, right, or on your data store. So instead of normalizing tables, for example, to reduce the number of duplication of string type values, for example, which is like actually a little bit heavy to store, what you do instead is to denormalize your schema and your whole application, so that way you can access information easier in an easier fashion, but at the expense, of course, of having a lot more storage. So as I said, in the free tier we have 25 gigabytes. This is a small application, so I don't think it's going to use like not even a fraction of that. But anyways, as I said, we're going to design this in such a way that it can scale to the needs of anyone, and we can actually extend the functionality and extend some other modules. So yeah, we have to take that into consideration as well. For the database schema, we're going to use a simple table design. So of course, we only have one entity, which is like a shortened URL. So we're going to use a single table for DynamoDB, which is going to be these four attributes right here, right? So we're going to have a slug, which is going to be a unique ID that we're going to use for uniquely identifying the URL that we're going to use, or that we're going to shorten, so to speak. Then we're going to have the original URL, which is of course going to be related to a slug. So a single slug or identifier is going to be directly related to an original URL. This is just so we can perform the redirection, right? So then we also have a creation date just for metadata purposes, and then finally we have a click count, which is going to be like a first approach of tracking some extra information aside from the fact that we can redirect the user to the original URL, right? So I have no idea how to implement geolocation or whatever it's called. So I don't know how to track the user's location when it's clicking the link, right? So we might add that in the future. Right now, I don't have an idea how to do that. So of course, we're going to leave that as for last, right? Then, even if we add more entities in the future, we're going to design this table in such a way that we can actually add those entities in the future, right? So we're going to keep the single table design that is actually promoted by even the AWS engineers. So I think they actually encourage you to use a single table for all of your entities in your application. So it's like really complex to design data around many entities in a single like logical container that is a table in DynamoDB. But it's an actually a really interesting exercise, a really challenging one, I would say, but also a very rewarding one because when you actually design your data in the right way, I mean, it's just it's beautiful, right? Oops, sorry, this thing keeps pulling off. We're going to find a better setup for the future. I promise. I promise. And then finally, we have an application structure and design pattern. So of course, wait. Yep. So as I was saying, the application structure, it's going to be fairly simple as well. We're going to use a layered architecture. We're going to separate our application in 3 main layers, I think. The first one is going to be, of course, the model, which is going to be the one that is in contact with our database and defines all of the schemas of our data. Then we're going to have the domain layer, which is going to define all of the functionality and all of the operations that you can perform over the models. And finally, the application layer, which is the highest level of our layered architecture, of course. And it's the one that's going to hold all of the endpoints, right? So the one that's going to be in contact with the Lambda function, and of course that is going to be in charge of redirecting the requests of the API gateway. Then finally, we're using Golang, so of course we need to use the factory methods. We're going to use the create new something, blah blah blah, or create new blah blah blah, which is just going to be useful for setups and to return new objects of certain types. So of course, if we're going to create a store, we're going to need a new store method, so to speak. So if we're doing a shortened URL store, we will need a new shortened URL store to create a new store of that type and then pass it to the domain so that it can perform some actions into that store, of course. So again, it's a very simple architecture. I mean, nothing too fancy, nothing too complicated. We're not going to be focusing too much on that on this project. Of course, we're going to do more complex projects later on, but right now I'm rather trying to focus on the cloud computing part, which I think it's like the most important, right? The most important one for me right now. So yeah, that's it for the context of the project. Then I also want to talk about a little bit about the setup that I have right now. So yesterday I was doing some preparations for this, and wait, let me just check something. So we're going to launch our Visual Studio Code. By the way, sorry, because I'm using light mode, but this is my new era, so new era, new colors, you know what I mean? So, as I was saying, a little bit of the context of the project that I'm working on so far. I have a little bit of scaffolding done. I was doing this yesterday, so I have done this like I think twice in the past. I haven't done this like formally with all this preparation. I was just doing like a bunch of trial and errors, and I mean, just trying some stuff out. Nothing really too serious about any of this. But for example, I have defined already all of the store and the database connections. So right here we have the code for connecting to a DynamoDB. We have the new DynamoDB client, as I talked about earlier. We're going to use a lot of this pattern functions thingy, where we can just call this function new DynamoDB client, and then in our application or on main entry point of our application or code base, we're going to call this function, and then we're going to pass it down to the domain, which I have defined here, which it just defines a bunch of methods that we're going to use and are going to operate over our models. So our models, I think, yep, here we have our models. We only have one right now because, of course, we only are managing the shortened URL model and sort of entity, so to speak. So yeah, we have all the attributes that we described before. So in our planning, we defined the primary key, which is going to be the slug, which is right here, the original URL, the created ad, and the click count. So we're going to use those 4 attributes in our DynamoDB table, sorry. And then, of course, all of the operations are defined in the domain. So yesterday I literally just did the create new shortened URL. So for this slug, we're going to use UUID. So for this one, and I was missing something right here, we need to take the first 7 digits of the UUID, or digits rather, characters of the UUID. So we're going to take a substring of the UUID, which is going to be like the first 7 digits, I believe. Let me just check something. I think that we can do just the first 7. Let's see, 3, 6, 8. Actually, there are 8 characters of UUID. So we're going to take the first 8 characters, which is going to be this right here. And as you can see, if you generate many UUIDs, it's going to be all different, right? So it's very difficult for them to collide. And that's why I'm doing it this way. I'm not sure how big pages of short URLs do this, but I just thought it's going to be like the easiest way to do this. So yeah, I mean, we're going to do it this way. It's enough. This is complicated enough for me to start thinking about how to generate new IDs and just cryptography stuff. I mean, you know, we're trying to center around the whole architecture thing. So yeah, I'm not too worried about how to generate these slugs. I mean, as long as they are unique, it's completely fine, you know. As long as they are unique, and of course they are not auto-incremental, because I'm not going to do like 1, 2, 3, 4, 5, and that's just, I mean, it would look really ugly, so I'm not going to do that, of course. So yeah, by the way, I've forgotten a lot of things about Go, so if you see me struggle a lot with functions and how to do basic stuff that you would do in any other programming language, and just Google it out or asking the AI. I mean, just don't blame me, okay? I mean, I haven't programmed in Go in like a long time, so yeah, I'm sorry about that. But yeah, I mean, right now, as I think it's a good time to start. I mean, as of now, I'm just missing the redirection system and of course defining all of the fiber endpoints, so I haven't done any of the application layer code. I have just done the store code and the domain code, and of course defining the models. So I haven't even done the CDK stuff yet. I mean, I haven't done pretty much anything, just like the basic setup, the things that are more annoying and maybe not too enjoyable to watch someone code. So yeah. By the way, the CDK code, as I said, I have nothing here, but of course we're going to define all of the things that we included in our diagram into the CDK. So of course we need to configure the API gateway, the proxy resource, the handler, the lambda, and then of course define the table for DynamoDB, which is just a really simple table since we only have a primary key right now. So yeah, let's keep going. By the way, I have a timer right here, over there. So we're going to do Pomodoro sessions of 50 minutes each, and then a little rest of 10 minutes, which is just going to be like, just for me, not really for like anyone watching, you know. But oops, sorry. So just to keep things a little bit more organized, and of course, I mean, I also need breaks, so yeah. So yeah, I mean, hopefully it's a nice journey that is going to begin right now. So yeah, I mean, I hope you enjoy. I think I will enjoy it a lot. I mean, one of my dreams since I was a kid is just to create some content. So yeah, I mean, I think it's going to be really funny. I'm not trying to be like professional or anything. I mean, if it turns out that way, well, so be it. I think it will be fun as well. But I'm just doing this because of I think it's going to be really helpful for me and hopefully for other people. So yeah, I mean, let's have fun together. Let's see if I don't mess up absolutely everything trying to do this. So yeah, let's get things started. So as I said, first thing we're going to do is to, well, basically we're going to first fix this. So we're going to do a substring for this. By the way, I'm not doing the AI completion tool, so I could, of course, but as of this project, as I think it's really just a simple project, we're not going to use AI for this or like Copilot. So I'm just going to code it out. I mean, I think it's way more fun that way. So yeah, let's see, Golang substring. I promise I haven't done this in like a long time. So yeah, let's see. Yeah, so I think we can do this in a simple way. So we can just do something like slug equals slug, and we could just do so from the beginning we want up until character number 8. So I think that's it. Let me just open Go Playground since my beautiful editor doesn't want to load the Go linter. So let's see how that works. So if we define a new string, oops, let's say something, and then we just do print line new string. Let's say we want to extract the first 5 characters, I guess. Let's see, run something. Yep. So if we paste UUID that we were looking at before, let's see. Oops, sorry. If we look up here, we replace that up there. It should just print out these characters. Wait, sorry. There you go. Should print up until the 8. Yes, okay. That is right. So we're going to just by the way, I don't think, let me just check if this is actually legal, because I'm not sure. Yep, okay. So we have already done this thing, so we're going to commit it. I'm using Git, of course. Sorry, here. Git add git commit lambda fix the slug system to include a substring of the UU. Okay, I haven't created a repo on GitHub, by the way, so we'll do that later. So yeah, we fixed that one. So now we need to do and to implement the, I think I left it in like where did I, here, yeah, they get original URL from Shorten. So all that I'm doing right here, it's literally just querying the DynamoDB table using the shortened URL and then populating an object that I defined in the model, of course, right here. So I'm just literally populating this object based on a slug. So as you can see right here, we are using, wait, let me just close some stuff. There you go. As you can see right here, I'm using this shortened URL parameter right here, and then we're going to use that to query the database in such a way that we get in return all of the attributes, and then we can just populate the object or the model that I showed right here. So we're going to return that, of course, or rather a pointer to that, just so we can return nil, of course, right here. So if we fail, we can return nil. In other ways, we can return a pointer to the model. And so I think this works good enough. If not, we're going to wait for it. By the way, I haven't done any testing. I know I should do some tests because that's what cool people do. But I'm not too cool yet. So I guess we'll have to see that a little bit later on. Maybe in the next project I will do some TDD or some tests, even if it's not TDD or too rigorous or, you know, like thoroughly testing. But I think it's just an interesting exercise nonetheless. So yeah, I mean, I will implement some testing eventually. Also, by the way, I think you can actually test your DynamoDB tables. So right here, yep, right here. I mean, I don't even know where did I execute the Java command, but you could just do like Java. I think it's right here. Yes, and now you can just connect and query DynamoDB right here. Yeah, so I haven't created any tables, so I mean, I guess if I wanted to test something, we can just do like a whole test suite where I could just connect to the DynamoDB local server and then just perform all the queries normally, just with a local connection. And then when we deploy to the server, we're going to do those same queries, but in the server, of course. So if I ensure that it works locally, then it will work in the server, that if that makes sense. So yeah, that's, I think, an easy way to test the functionality and just the operations to your database overall. But as I said, we're going to do that on a later project. Right now, we're just focusing on the main stuff. We're focusing on getting this thing completed, functionally completed. So yeah, I have this method defined on the store. So right now we're going to do the same thing on the domain layer. So right here. So for this, of course, we need to get so func s, which is a pointer to the store. We're going to do get, how was it called? I think I'm naming this the same way as this one's. I believe, okay. So for this one we need the context. So context.context. I'm not entirely sure on why the whole SDK of AWS uses this context. I think it's just for some internal stuff, but we need to pass it. So eventually we're going to create a context, maybe in the app layer, for example, and then we're going to pass it down all the way until the database. I'm not going to use context for anything, I believe, right now. I mean, context is not a very advanced topic, I think, but I mean, I'm still not sure in which cases to use it. I guess I will have to do some more research about it. But I think it's, I mean, I know for a fact that it's a very popular thing in Go, just for do some setup and configuration stuff, for the same way that AWS is using it, I think. But as I said, I mean, I'm not going to use it manually in all of my endpoints, so yeah, I mean, it's just like a requirement for the whole framework of AWS, I think. Or the library, rather. Or package, or whatever it's called in Go. Jesus. So, as I said, we're going to use URL or shorten URL, rather. URL, which is of type string. And as of this, we're going to return, I think, just an error. Basically, let me see the signature of this one. Shorten URL or error. Oh yeah, I think that actually makes sense. Model and then error. Okay. And then we're just going to define here our shorten URL object, which is going to be just a pointer to, or rather not a pointer, but just a struct right now. We're going to define here shorten URL, and we're going to just return nil for the error. Okay, so as I said, right now we need to first and foremost, we need to parse the input. I mean, in this case it's a string, so I guess we don't need to parse anything. But here in the database function, we have defined some error validation. So if we don't find the slug, we're going to return that error, of course. So we can just like call it directly, right? So I think we could just simply do s.get original URL from shorten. So we pass in the context, we pass the shortened URL, and then we're going to call an error. So we can use a snippet here. We can do return nil and then error f. And we can just do something like failed at the domain layer, and then just print the error value. Okay, and then we can just return this like so. Okay, so nothing too fancy, as I said. I mean, actually the domain layer, it's one of the most unused ones, at least for me in past projects, basically because I mean, I think conceptually it's just a layer for performing a lot of validations and just parsing the inputs and just like abstracting the whole process from the API to like a domain. So it's sort of like a controller layer, but I mean, I just haven't found many other use cases rather than just parsing input and validating. So yeah. So we're getting a warning here, infinite recursive call. Wait. What do you mean infinite recursive call? I mean, we're not doing anything recursively right here. Wait. Get original, that's the only one right here, and then I don't know if like we need, nope. I'm not entirely sure why we're getting that one, but Oh, I think it's because we haven't defined that in the store. Wait. Where is it? Store. There you go. So probably like this, and then if we go back to our domain, the error is gone, or warning rather. So yeah, that makes sense. So let's just commit that. Where is it? Here. Git status. So we're going to add all of this stuff right here. We're going to do lambda. Defined method for querying a shortened URL info in domain layer. Okay. So essentially, we have defined all the functionality for this URL shortener. So after that, what do we need to do? Let's see. So we have defined this. I think we need to define this right here. So for our store, what do we need for our store? I mean, not much, I would say. So we're just going to do like a pointer here. I mean, I think I need to return this, right? Right? I think we could just like here in the domain in like definitions, we could just do something like func new store, and then we can just do dynamodb.client. Is it that way? And then we can just return a store with so return a store pointer, and then we just do db client right here. So of course we need to import that store shorten URL store. Okay, I think that's the way you should do it. I'm not entirely sure if it's like optimal, but I mean, we'll just go with that one. And then this warning is back. I'm still not sure on why this is happening, but I mean, I think that's good enough. I mean, this thing is just kind of crazy, but oh wait. I think I'm okay. There you go. Yeah, that was a bit crazy. Why the hell am I doing that, bro? Infinite recursive call. I'm still not sure on why that happens. Wait. Infinite recursive call. I mean, what? Oh, wait. I'm stupid. There you go. You donkey. That was funny. Anyways, so we did this. I think we can just basically another thing. lambda defined creation method for store and fix whatever. Oops. Not what I wanted to do. Okay, there you go. Okay, so we defined both of them. So we basically just finished the bottom two layers. So as I said, we're going to use the store layer, then the domain layer, and then the application layer. So right now we're just missing coding the Fiverr application. So I'm just going to do everything in a single file. I mean, I'm going to title this, I don't know, API, for example. Okay, so now we need to do the Fiverr stuff. I haven't tried Fiverr in like months or even years, I would say. So I don't remember much of the stuff here. Recently I used Hono for TypeScript, but I think it's fairly similar. I mean, they are both inspired in Express, I think, so, I mean, it's the same stuff, just these guys did a different programming language. So anyways, we're going to copy this, we're going to install it, so go get Fiverr v2. And then, I mean, yeah, it's fairly simple. Malformed path get missing dot in first path element. What? Oh, I'm stupid. I copied the whole thing. Anyways, yeah, so you just instance the application, then you start doing all of the methods and defining the functionality. I mean, that's fairly simple. Okay, so that's exactly what we're going to do. So we're just going to add a main function here, and we're going to do fiber.new to create a new application, and then we can just start doing the routes. So for example, I think there should be like a grouping method. There we go, grouping. So we can just do like v1, and then we can just do app.group, and then we can just do /API/v1 just for versioning, of course. And then we can add some middleware as well, but we're not going to use middleware right now, so we're going to leave that empty. And then we can just do our get methods now freely. So for example, declare not used. Anyways, so the first endpoint that we're going to use is the get shortened URL. Or no, let's do the post one first. So we're going to do post, and then we're going to do shorten. Or, I mean, I don't know naming conventions in REST APIs. This is always a conflict, like, what the hell am I supposed to name my endpoints? I think it's just like a lifelong conflict that everyone has. I'm gonna just keep it simple. We're just going to call it shorten for both. So we're going to use v1.post and v1.get shorten. I don't even have a name for the application, so I don't think it's all that relevant. But we're going to do it that way. Anyways. So now we need to define our handlers. I think it does have like some type of signature, so we're going to check that out. Handler, yeah, it's just a context function, so we're going to use it that way. So C, fiverr.ctx, I believe, and then we just return an error. So yeah. Okay. So we can just do something like C string send string, and then this is working, right? So for example, we're going to do that. So as I said, we're not going to do anything too fancy, so let's just do listen and then port 3000. I believe you can just like listen directly here. Yep. Log that fatal. We're going to do that just cause. Okay. So we're listening our application. I think we can just like safely just do something like go run application slash api.go, and this should oops, command line arguments is not a main package. Oh, wait. Execute API, and then we're just going to call it here on the main, I guess. Func main execute API. Sure, we're just going to call like application, and then if we go here, of course we need to put it in uppercase to export it. Execute API. So now we go to main, execute API. Then we can just import the application package. There you go. I think that should be good enough. Go run main.go. Missing handler in route. Oh yeah, that's true. We're just going to copy this one. We don't care about the details right now. So anyways, go run main.go, allow access. Let's see, so port 3000, cannot get slash. Okay, so now if we just go to API v1 and then shorten, this is working nice. So yeah, that defines our route basically. And I think we can just use this for the application layer abstraction as well. So yeah, we're going to leave it this way. As I said, we're going to do all of this in a single file since this is just a really simple API. I think there are tutorials on the webpage on how to do it on multiple files. So if you actually go to the webpage, sorry, no, what the hell am I doing? Okay, so if you go to their webpage, they have a routing section right here. And then here you can check how to split like the whole function things, so you can define the handlers on separate files and then you can just import them and use it right here, which is really convenient because then you can split your application, of course, and make it more modular, so you know exactly where to edit if you ever need to edit some endpoints or whatever. So yeah, let's see, 26 minutes. I think we're doing fairly decent for it to be our first live stream, whatever. It's fine. So, what's our next move? So, as I said, we have defined our first two layers. So our next move should be to configure the whole Fiverr thing. So, okay, so let's just focus on this file right now. And let's see, so for posting it, what we should do is we should take a payload, which is just going to be a single attribute. So for example, I'm going to go to Postman. Let's see. I will just go to Postman, sign in. So we would need a single JSON payload with a single attribute rather, which is going to be like the original URL. And then that's the thing that we're going to pass down to the domain layer, which is going to perform some validations. And then that's the same thing that's going to be used in the DynamoDB layer to perform the operations. So let's see. Oops. Let me just go to workspaces. And then we're just going to define a mock1, which is not going to work, of course, because we need the Postman agent. And then we can just do HTTP 127.0.0.1 API v1, and then we can just do shorten, and then we can just go to a post method. So now if we do this, then this doesn't run. Why is it not working? Come on. Anyways, so anticipating the fact that that's not going to work, we're just going to define our body. So for example, if we define, I think I have defined here in the requests, how is it called? I haven't. See, that's why you need to double check. Original URL, let's call it. So, for example, original URL. So this is going to be something like, I don't know, https://google.com. So we're going to be redirected to Google, of course. Then if this thing only works, please, 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 please. Let me just try again. Maybe this isn't working. Wait, what? Oh, it's because I haven't... That was so bad, like so bad. This is working, there you go. So, anyways, if we define our body, of course it's not going to do anything because, I mean, we haven't defined any logic right here. We're not even like capturing the input, but I mean, it is working anyway. So, as I said, we're going to do API. So we need to first capture the whole body. So just parse the JSON and just transform it into a Golang object. So that's why we made the request right here. So we need to marshal the body into the create shorten URL. And then we're just going to pass it down to the domain layer, which is what is going to be used right here. So, by the way, I think we need to do... Yep, that's exactly what we're going to do. Actually, let's see how can we do this. Type application, struct. So we're going to have a domain which is going to be of type... Oh yeah, that's also what I'm missing. So, okay, listen. We're going to do this firstly. So, I think here on our domain, we need to define an interface that's going to act as our thing right here. Okay. So, wait. We need to copy both signatures right here. And we're just going to paste them. Of course, without this right here. Okay. And then the other one, which is fairly simple. Let's see, definitions. Just get rid of this, get rid of that, and then, okay, all the imports are correct. So let's see, so let me just think about it. So we have a domain which is performing some operations. And then so we would need to create like a factory again, I think. So something like new domain, but what are we going to return? That's just, I don't know. Maybe, how did we do it on the database, by the way? DynamoDB store, and then as for the store, we also did, I think, yeah, we did it here. So we have a type domain interface, and then we have a store, which is a shortened URL store, which is of type, that type, okay. So why don't we do this like domain.domain, and then we're just going to do like API, which is just going to be like fiber.up, or I mean, I don't even know how this is called. Domain hopping. What? Okay. So this is the type of this one, right? Okay, yeah. We're going to do a pointer to an up, just to be more precise. And then as for the domain, we need a way to create new domains, which I think, wait, store. So where's the creation of the store? Mm, I'm not even sure if this is the right way to do it. I mean, we're just going to leave it this way for now. I'm going to fix it later on if I find it's not the right way to do it, but I think it's just good enough for now. So let's see, func new application. So we're just going to do an app, which is going to be a Fiverr app, of course, and then we're just going to return a new application, which is going to have its domain set to, well, I mean, I will need to just wait, let me just check it right now, because I have like a trial project right here. Let me just check it, because again, I'm not entirely sure on how to do that. Let's see. Lambda domain users. So for example, if I wanted to do like users struct new users domain, so literally like this return a users. Oh wait. So if we go here, if we wanted to define a new domain, we just need the store, which we have right here, and then we would need to create a new domain, which is going to be, of course, of type pointer store. Okay. Type, sorry, domain. So we would just, okay, wait. User store, user domain. Okay, and then in the application layer, so in our functions, let's see how we did this. So we have our user's domain, then we have our handlers right here. So if we go exactly over here, we have to pass down our coupons or users API gateway handler. Okay, then what is this? It's just a struct, and then in the handlers we're just going to operate over that. Okay, I see how I did that last time. So I guess it's just like a layer on top of the fiber router. I think it makes sense, but I don't know if it's the most optimal way to do it, because right here I'm doing it with the API Gateway SDK. So I'm not using any framework, I'm just literally using like the native events to manage the requests directly in the API Gateway. So if you check the CDK for this application, you would see that I defined all of the resources directly up there. And by the way, I have defined all of these functions right here. So if we go to, let's see, main.go. So for example, if we go to the user function, you would see right here that I'm just literally doing a switch statement to the requests, and then I'm doing just this filtering and defining all of the methods right here. But we're not going to do that on this project, so I don't know if it's the most optimal way to do it, but we'll see. Okay, we will just carry on with it. I don't think it's that terrible. We could make it work. If not, I mean, I'm just going to check it out later, but I think it makes sense right now. So, we're creating our new domain. So this is returning a store, and then right here, instead of returning a store, so on our domain layer, yep, on this file, we're returning the users, which is just a struct. Oh, wait, what am I doing? So this should be called domain, and then this goes out, and then we were just returning a domain, which just fixes that. Okay. So, yeah, I mean, what am I doing? I called a store, and I had a store right here. What am I doing? What am I thinking of? I am crazy. So anyways, after fixing a little bit of a dump moment right there, actually we'll call this store just to make sure it's consistent with the naming. Yeah. Okay, yeah, that makes sense. So what we can do now, it's so this operates directly on the domain type. So let me just change that. Let me just do s stop. Let's change it for domain. I'm gonna wait. We'll just change it manually. It's not that big of a deal. Store. Okay. So we changed both of them, and then now here we can just call it like new domain, domain.new domain, and then API. We can just do something like app fiber.new, then just pass the app right here, right? So we just do that. Then we can just return a type application right here. So we can just make this a pointer, and then okay, nice. So we can just by the way, I'm using this already over here. New domain, so we would need the store as well. So we could just do store, shorten URL store. So we just pass it down right here. I actually don't think we need this anyway, so maybe we do, maybe we don't. Maybe we could just pass the domain directly. I mean, domain.domain. We just do something like domain here. Nice. Okay. So that fixes most of our problems. But we have new problems. So of course, that's the beauty of coding. Let me just remove this thing because we don't need this header anymore. Let's just stop the server right now, and then we will just add a new commit lambda, fix some details on the layers, or actually let's be more descriptive. Fixed domain layer inconsistency. I mean, nobody has to know, right? Nobody has to know that I'm so dumb, but I guess everyone on the internet could know since I'm live streaming this. But who cares? So we have all of the methods that we needed. The execute API method, I mean, it's going to be like just, I think we don't need this right now. So, I mean, just for testing purposes, maybe we could just do something like application, and then just do something like execute, and then we can just do something like app.api.listen on port 3000, and then we can just do the log data as well. Okay, so we can call that one when we're ready after all the setup and after all the things. So I guess that makes sense. And then we could actually start defining all of our methods. So we can just do something like shorten URL.go. I know I said that I was going to do a single file. I mean, just for consistency, I'm going to do several files. I mean, not several, but just a separate file for each module and like functionality. So we're going to do a separate file for shorten URL. Of course, in the future, if I decide to extend the application, we're going to do more files for each of the functionality that is going to reflect in the application. So, I mean, yeah, I think it looks way better that way. Let's see. So, application, we're just going to do execute, or no, we're going to leave that one over there. So the first one, of course, it's going to be to define our handler for post shorten URL. So of course we're going to do app.api.post, or rather, let's just do, or wait, actually, we could pass in the group right here, and then the group is not exactly an application, is it? Wait. Let me just try this. App API group. So what is this exactly? This is a router type. We could just pass in the router right here actually. Maybe. And then just put it over here, and then we wouldn't need this. So we're going to just define the routes inside this, and then on the main function we're going to call the listen function of the API itself, or rather the Fiverr app itself. So right here we could just do app. I think it should be more consistent if we call this something like router. So we will rename that, and then we could just do something like app.router.get, for example, right? Is a pointer to interface, not interface. Oh wait, so is it? Wait, is it router? Yeah, so this is an interface. Wait. Wait a minute. Group router. So where do I search for group router? Type group. I think this is the one we need. Okay. Nice. Group. So we're just going to call this Fiverr group. Okay, so now that's allowed. So of course this is a post method. So we're going to do the same thing here. So func ctx pointer to Fiverr.ctx, and then we return an error. Oh, by the way, oops, is that over there? Okay. So I'm tempted to just try if this works. Like, I mean, even if this works, if this even works. Let's see, ctx dot string, rather send string. Let's just call this main thing for sake of simplicity. C dot send string. By the way, this is b2. See if that auto completes. Send string. There you go. So we can do that right here, and then if we just do something like, I mean, I guess I cannot. I cannot try that directly right now because I haven't defined our database. But Anyways, we're just going to take a leap of faith, okay? We'll just assume this works for now. So we need to parse the body of this thing. Let's see, how can we parse the body? Context, body. We can do body or body parser. Out. Oh, that makes sense. I guess we could do that one as well. Let's see. So we can just do something like create shorten request, and then we can just do something like requests create shorten URL request, which is just an interface, and then we can just do if error c dot body parser, and then we just pass in create shorten request. And so if this is not nil, so that means there's an error, we're just going to do return the error. And then otherwise we will just do app dot domain and then dot create new shortened URL, and then so we need to pass in the context. We need to pass in the context. Okay, we'll just do it here. And then we're going to just pass in ctx, and then we can just do create shortened URL, create shortened request. Sorry. So this thing right here, I think it returns an error. Jesus. Shorten URL and then an error. Okay. So if error. And then we're going to just do c dot send string. Do you think, wait, no, this is string. We need to stringify that one first. So how do you, let's see. How was it again? JSON.Marshall. Wait, was it that? I think it was. So this returns. What is this supposed to even return? So we're going to call this like res, I think. This returns a byte and error. So we could just call it that way, I think. Then we can just do shorten URL, and then we can just do c dot send string, and then we can just convert this to a string. I think that makes sense. Does it? So we can just do something like error f, error marshalling new, how was it? New shorten URL. It is time, guys. So for this time, just because it's my first time doing a live stream, I'm just going to do 1 Pomodoro, but I'm planning to do around 4 approximately per live stream. So yeah, I mean, that was really fun. I'm going to keep just polishing this project outside of the live streams. I will come with a report in each live stream, so yeah, I mean, don't worry if I make any advancements, I will tell. But right now, I mean, I think it was decent progress. I mean, you know, it was our first time doing a live stream. So I wasn't expecting to do a lot of progress, but I think that was pretty nice. I mean, we basically finished the post shorten URL. So yeah, I mean, I think that's it for now. Um, I will test this out, basically this one and everything basically. So let's just fix this. Okay. Um, I'm going to commit all the changes. Git commit. Added the first route 4. Other added the post route 4 API. So we just commit that one. Not a whole lot of commits yet, but this makes sense. Okay. So yeah, I mean that was it for now. We're going to leave it at that. As I said, I'm going to perform some advancements outside of cameras. I think it's a really fun project, especially the part of the deployment, the whole cloud architecture thing. Not a very interesting one in the sake of functionality, but it's just like a first approach to what I want to do and what I want to specialize eventually. So I mean, yeah, that was really funny. I guess it was the first time. So, anyways, we're going to leave it at this. I hope y'all liked it. As I said, I'm going to be documenting my progress over time. So, yeah, that's it for now. Goodbye, everyone.